Okay, continuing with resistors. This is resistors in parallel. So what does that mean? So if resistors are in parallel, is it two L's? Yeah. Is that right? I don't know. You kind of lose it when you're doing something on the board or on video. So if they're in parallel, they have the same change in potential. And that means they have to have share two nodes, two endpoints. So let's take these two right here. These 2 points are common for both of them, and they have the same potential. And I know that because let's call this change potential delta V1 and that delta V2. If I do the loop rule says delta V around a loop is equal to 0. So if I go around this loop, I'm going to get, if I do this loop, then I'd have delta V1 plus delta V2 equals 0. So they have to have the same change in potential because they have to add up to 0 or negative each other. So that means those two are in parallel. Okay, so what I want to do is to find if I have two resistors in, and this is true for anything in parallel. You don't have to have just resistors in parallel. If I have these two resistors in parallel, I want to find one resistor that would give the same total current coming out of the circuit. So let's say here I have the current I coming out of the battery. Now, at this point, we have a problem because I comes down here into a junction. And so that's my loop rule. My junction rule is I in equals I out. So here I have a current coming in. I have to have the same amount of current coming out. So let's call this I1 and that I2. So that means I equals I1 plus I2. Now let's do our loop rule. So the goal here is to find an expression for the total current. Okay. And then I want to make sure that this has the same total current. So if I do this loop, the big loop, I'm going to do the big loop. So I'm going to start right here. I'm going to go around this way and add up all the voltages. So here the first one I have is EMF. And then I go over here. Now I have minus I2 R2. And then I get back to where I was. See, I didn't even go through that resistor R1, so it doesn't even matter. Okay. So if I use this right here, let's see. I want to find I1. So there's I2 right there. Let's do the same thing for this. That's I1. This loop. So I also get EMF minus I1 R1 equals 0. So over here, I can say right here, I can say I2 equals EMF over R2. If I add this to both sides and divide by R2, and then here I can say I1 equals EMF over R1. So if I go over here and say I equals I1 plus I2, that's just going to be EMF over R1 plus EMF over R2 equals EMF times 1 over R1 plus 1 over R2. Okay, now let's say I look at this circuit up here. Now I have this, I want to have the same current. So if I do the loop rule for this one, it's easy. You have EMF minus I R equivalent equals 0. So if I solve this one for I get I equals EMF over R equivalent. So that means that R equivalent has to be equal to 1 over this. Or I could say 1 over R equivalent is equal to 1 over R1 plus 1 over R2. And that's how I find my parallel resistance value. So if I have resistors in parallel, I can replace them with 1 by taking 1 over resistance R1 plus 1 over resistance R2, and then that would be 1 over the equivalent resistance. Okay, that's a big mistake I see people make. Let's do an example, and then I'll give you a generalized formula. So let's say I have this. $10 ohms. Oh, I didn't put the resistor there. 20 ohms. So this is equal to, so R1 is 10, R2 is 20. So R equivalent, so I could say 1 over R equivalent is equal to 1 over R1 plus 1 over R2. So it's going to be 1 over 10, I'll leave off the units, plus 1 over 20. So now I can multiply this side by 2, top and bottom, and I get 2 over 20 plus 1 over 20 is 3 over 20. So then 1 over R equivalent is equal to 3 over 20, which is so R equivalent is equal to 20 over 3 ohms. So that's the important part that a lot of people skip. A lot of people just put, oh, 1 over 10 plus 1 over 20, that's my resistance. And that's not it. It didn't even have the right units. This has units of 1 over ohms. That's not the resistance. Okay, so it's 20 over thirds. 20 thirds. Now, the other thing that's important to look at here is that this resistance is less than this. It's less than 10 ohms, right? Because if I take 20 divided by 2, I would get 10. But I'm taking 20 divided by 3, so it's less than 10. It's also less than 20. So the equivalent resistance of 2 resistors in parallel is less than each individual one. Compare that to resistors in series. And this is in a previous video. R equivalent is R1 plus R2. It's bigger than each individual resistor. Okay. What if I have 3 resistors in series? What if I have this? R1, R2, R3. So you'll notice that they all share the same endpoints. So they are indeed in parallel, and you can have resistors in parallel. In that case, 1 over R equivalent would be 1 over R1 plus 1 over R2 plus 1 over R3. So, and you could keep doing this as long as you want, but you have to add them as fractions first and then take 1 over that to get the total resistance. And that is resistors in parallel. Now, there is something else we can do with this. It's called a current divider, and I'll show you that in the next video.